Hey everybody, welcome back. Today we're going to be doing some more mathematical calculations and understanding of the electric field. There's two formulas, but we're going to do the first formula today, and then we'll do the next one in the next video. Okay, so we learned about electric fields, we learned how it's not a force, and how it emits a field for a force if a charge goes near it. So the stronger the charge, the stronger the electric field will be, and vice versa. The further away the point is from the electric field will be, the weaker the electric field will be. Positives emit an electric field outward, and negative emits an electric field inward, as we learned. So here's some variables. This capital Q is the source charge. So this is where like the electric field is emitting from. This E is the electric field. R is how far it is from the charge or from the field. And the K is the K's constant. Okay, so here's the general equation. And if we want to find the electric field here, for example, we need to know what this charge is, Q, and we need to know how far it is from that charge. Okay, and we could find the electric field here, here, or anywhere, as long as we know how far it is and how strong the charge is. Okay, so that's the basic idea. Let's do some example problems to clarify this a little more. Okay, so conceptual example 15. At what point will the electric field be the strongest looking at the diagram below? A, -2, B, 0, C, 2, D, 3. So -2, 0, 2, or 3. Which one would have the strongest electric field? And that hopefully that should make sense that it's going to be -2. Why is it -2 going to have the strongest electric field? Well, that's the one that's the closest to the charge. So the closer it is to the charge, the stronger the electric field is going to be. Okay? Moving on. As shown in the diagram, Q1 has a charge of 2.5 coulombs and is located at -3 meters. What will the electric field be at the location 0 meters and 3 meters? Okay, so first we want to find what the electric field is over here. I'm going to call this E1. And then what the electric field is over here, E3. I don't know what it is yet, but I do know one thing. I know it's going to be pointing to the right for both of them. And I also know that 1 is going to be stronger than 3 since 1 is closer to the source. Alright, so let's figure this out. The electric field of 1 is going to be equal to the KQR squared. If we look back at the formula, oops, sorry. This is where we get that from. Okay. All right. So now let's plug this in. We have 9 times 10 to the power of 9. Q is 2.5 coulombs, and how far it is. So this is going to be a distance of 3 meters away. So that's going to be 3 squared. So I'm going to put this all into my calculator, and let's see what we get. 9 times 10 to the power of 9 times 2.5 divided by 9, and we get a big number, 2.5 times 10 to the 9th newtons per coulomb. Okay. Part B, we don't know what it is, but we do know it should be less than that. So electric field 2 is equal to KQ divided by R squared. So this is going to be 9 times 10 to the 9th times Q, which is 2.5, divided by how far it is, and this is going to be 6 meters away. So this is going to be 6 squared. Okay, so let's figure that out. 9 times 10 to the power of 9 times 2.5 divided by 36. And then we get around 6.25 times 10 to the 8th Newton per coulomb. Okay? And as we confirm, it's just confirming what we thought before, it will be less. All right. Hope that made sense. I did go a little fast, so if you need to look at it again, please do so. Moving on. A particle has a charge of 4.2 coulombs. Let me just kind of write that down. Positive 4.2 coulombs. At a point P, there's an electric field with a magnitude of 945,000 Newton per coulomb. So there's going to be an electric field here, and that's going to be equal to 945,000 Newton per coulomb. what is the distance P is from the origin. So we're looking for this distance. I'm going to say R. Okay, so we know the electric field is equal to KQ over R squared. And we can manipulate this by doing R is equal to K over Q divided by E. And since it's a square before, we're going to square root that. Okay, so let's figure this out. R is going to be equal to the square root of K, which is 9 times 10 to the 9th, times the charge Q, which is 4.2, divided by the electric field, which is 945,000. And let's see what that's going to be equal to. 9 times 10 to the power of 9 times 4.2 divided by 945,000. And then the square root of that is going to give us, it's going to be 200 meters away. Okay? All right, moving on. Looking at the diagram below, point P is 0.6 meters from the origin and is experiencing an electric field of 800 million Newton per Coulomb. What is the charge Q? Okay, we don't, let's assume that this is positive. So this is going to the right, the electric field at that point, which is 800 million. Oops. And then we know that this is 0.6 away, 0.6 meters. All right, so let's figure this out. What we have, electric field is equal to KQ divided by R squared. But what we want to do is we want to figure out what Q is. So we're going to do some algebraic manipulation. I'm going to do E R squared divided by K is going to be equal to Q. So let's plug this all in. E is equal to 800 million. R is equal to 0.6 squared divided by K, which is 9 times 10 to the 9th. And let's see what this is. 800 million times 0.6 squared divided by 9 times 10 to the power of 9. And we get 0.032 coulombs. Okay. Make sure that you put it into your calculator correctly using all of these parentheses and everything like that, because a lot of times I've seen that students get questions like this wrong by not putting parentheses inside their calculator. All right, moving on. Conceptual example 16. There are two charges on a distance line between both of which are forming an electric field as shown in the diagram. If both charges are equal in magnitude, which charge emits a stronger electric field at the origin? Q1, Q2, both charges emit the same amount of charge. Okay. We're seeing which one emits a stronger charge. Q1 that have the same amount of charge as Q2. We know that Q1 is going to make this go over here to the right. And we know Q2 is going to make this go over here to the left. I'm going to call this E1 and E2. But which one's going to have a stronger magnitude? You might be wondering, like, oh, they have the same charge, so they must exert the same electric field. But that's not true. Because Q1 is closer, this one is 3 meters, and this one is 4 meters, that means that this this electric field is going to be stronger than Q2 at the origin. So it'll be Q1. Hope that made sense. Next time we're going to be learning about another electric field formula, and we'll see how that works later on. Thanks for watching, everyone. Bye.